Okay, I'm restarting the streaming, just so that we can finish the trace, because we are really close to the end, and we got the return value specified, but we are not returning to the right place. So, um, this screen does not use the same resolution as the other one. So let me change that. There we go. All right. All right. So we just want to find out why the program is not doing it correctly. In other words, it is retrieving the stack. It's retrieving the return value from location FA, and instead of, because this is the increment. This is because of the increment of line 70. So it is not retrieving this the return address correctly in this code. So okay, so how do we figure this out? How do we know what has just gone wrong in this program? That's one of the things that is good about the trace analyzer. Is the trace analyzer itself is static. I don't have to run the program again. I don't have to single click using Control T. I just need to go back, because what I need to do is to look at the entry point of the subroutine and find out what the stack pointer is at the entry point of the subroutine. So at the entry point of the subroutine, when we push the return address, okay, I'm looking for the call to the subroutine. If you use the assembler assemble window of the assembler, you will be able to find all of that stuff pretty quickly. But even without that, this is where I store the return address, right here at location FA. So the continuation address is supposed to be 21 at location FA. Now I can go back to the end of the trace, okay. And this is FA. When I get to FA, because of this increment D, okay, this is totally my bad. I used the wrong opcode, the wrong mnemonic. It should not be LDIBD. It should be just LD. Yep. The assembler should have caught it, even though it did not, obviously. So it's a tool issue. It's time for me to debug the tool itself. But it should be an LD and not an LDI. And that's the reason why it did not work. So it's totally my bad. I totally screwed up the return instructions. So that accounts for everything. The passcode of today's lab, the one that's starting today, is FIB for Fibonacci. Now, Fibonacci is not due in a week and 2 days. It's due next Thursday. So after the break, we still have the Tuesday to talk about the Fibonacci program. And it is unlikely that I'll give you a new lab on next Tuesday. So you do have quite a bit of time to think about the Fibonacci program. But you should really start with understanding the current programs that we have been working on already. So are there any questions before I stop the recorder? Because I caught the bug and I think I'm good in terms of the program that I wrote today. Nope. Okay. Does anyone want to see the recursive version of string length and use the lab time for that? I think that might be a good use of lab time, because Fibonacci itself is recursive. Are we good? Okay, so we'll run with that. Okay. Okay. So So I'm going back to string length here. So the only change to string length is I do not want to use this code anymore. This is the usual practical implementation of string length. So instead of doing this, I'm going to use the recursive version of string length. The recursive version of string length, there are two ways to do it. One way is more cryptic than the other one. So one way is to use the ternary operator and condense the entire subroutine into one line. The other way is to use proper conditional statement. So you end up with like 5 or 6 lines. Okay. So which way do you guys want to see? Ternary. Okay. So the ternary operator says we only need a single return. That's the only line of the entire string length program. But within the return, we're returning a ternary expression. A ternary expression has a conditional part, which is this part here, a then value, and also an else value. Okay, so those are the 3 parts of a ternary expression. So what we need to know is whether str is pointing to something that is already null or not. Okay, if it is not null, then we're going to return 1 plus strlen string plus 1, because we are basically saying what string or str is pointing to is non-null. Okay, find out the length of the rest of the string, and then what my return value is just 1 plus that. Does that make sense? Yes? Okay. So what about the other one? What if str is already pointing to a null character? What would be the length of that string? No. 0. That's right. That's it. That's string length recursive. So now is the implementation of this. Okay, there's no local variable, no loop whatsoever. It's recursive. But this is a very good example, not related to assembly language programming, but this is a good example of how to look at a problem as one step and then a smaller version of itself. Okay, what is the one step? The one step is, okay, you have this thing that you want me to tell you what the length is. I'm lazy. Okay, I'll just say that what I'm pointing at is not, so it has at least 1 character. This one to the length of the rest of the string, but I'm not going to do that. You're going to do it. So the sub-problem is the rest of the string, okay, which is basically just str plus 1 being the beginning point of the substring. Is that okay? So that's the recursive way of looking at things. It is not specific to assembly language programming, but when you take cisp310 and cisp440, that concept becomes kind of important. Okay, so you get to understand, how to look at a problem as a sub-problem plus, a little extra things to do. Okay, so I will use. I guess I can use a new window. There we go. So I'm going to use a new window to implement the other one. I can keep main, because main, the caller has not changed. So I'm going to keep main the same as it was. Okay. All right, so this is the new code, string length. Okay. So I'm going to do the same thing. We'll start to have some, symbolic names and whatnot. So we'll have str colon 1. Actually, this is return address 1 plus, and then return address this time is 0 because we don't have a local variable anymore. Are we good so far? Okay. Okay. So what do we need to do? Well, when you look at a ternary operator, the first thing we need to do is to evaluate the condition. So we still have that same step that we have to do, just like before, except now it becomes the first thing that we need to do. So we can use the same trick with LDIB with str, add d to b. Okay, so that b is now the address of str, ldbb, and then another ldbb, because I need to look at what str is pointing to. So b is now whatever str is pointing to. I once again need to determine, is it a 0 or non-zero? So nbb will do that trick. JCI to not null, okay? And not null as a label is defined here. So over here, I'll just specify the logic to say what if whatever str points to is in fact null. Well, that's easy. LDIA with a 0, and I'm done. JMPI to end if. So end if is over here. If it is not null, I need to do a recursive call. So to do the recursive call, I'm just going to be a little bit, I cannot be lazy because I just got rid of it. So LDIB with str, add BD. So once again, B becomes the address of str. LDBB. So B is now str itself. And I'm going to stop here. I don't need another LD instruction because what I'm trying to do is to implement str plus 1. Str plus 1 is just the parameter itself plus 1, not what the parameter is pointing to. So I don't need the second LDBB. And what I do need is an increment, okay? So B is now str plus 1, and I need to push it on the stack. Decrement D, stdb. So we have just pushed str plus 1 on the stack. Now the rest is just a function call to str itself, which is no different from all of the other function calls that we have done. So we have a decrement D to reserve the space. LD, I can use B again, okay, 15 plus, which is the return address. stdb to store the return address on the stack, and then JMPI to the subroutine that I'm calling. Who am I calling? Not the Ghostbusters, but string length, right? Okay. So after string length returns, I have to clean up the stack because I still have the argument on the stack. So I have to increment D to get rid of the argument that is on the stack. But the return value will be in register A already. In other words, at this time on line 56 of the assembly code, I would have completed the recursive call to string length. But I take that return value and I say, it's close to what I want to return, except it's one short. So I have to increment A first before I actually return from the subroutine. Then I can just fall through to end if, which is the typical way of returning from a subroutine. This time I have to be careful not to use LDI, but LDE. So we have LDBD. I cannot use A because string length is using register A for the return value already. And then we have an increment D to deallocate the stack pointer. And then we have JMPB to continue execution in the caller. Now, what if the caller is string length itself? It doesn't matter. The mechanism does not change. So are we okay so far with this code? So how many people think the recursive version is actually easier to understand? It is going to be, it's not efficient, okay? So, if you have a choice, the recursive version of string length, despite it is more elegant from the looks of it, it is actually not efficient at all because it uses up a lot of stack space for one, and then every time you use stack space, it also incurs penalty in terms of execution time. So it's not practical to do it that way, but it is kind of cool to look at it as a possible solution. All right, so I'm going to run this code. Okay, I'll put it into the assembler to run it. There we go. And I will fix the assembler so it can catch the problem of an LDI, not BD not getting caught. So we go to source, Control V, and probably has some extra stuff that I don't need here. So get rid of the excess stuff, and we're good. And we go to download.
It says there are errors at the top.
There are errors? Oh, okay. I missed that. Register Y expected. Oh, LDIB, not LD. So it caught this one, but it didn't catch the other one that I made earlier. Okay, there we go. So download CSV Replace the other one, go back to the command line, repeat the command itself, go back to the trace analyzer, and re-import. It's still analyzing. The trace analyzer is using spreadsheet functions only, so certain things could have been done a little bit more efficiently. And let's see. Yep, so this time the program did complete correctly because the stack pointer is balanced all the way to the end of main. And register A, which is the return value, should have a value of 3 when we return. So let's check that register A. Uh-oh, it's not. Okay, what did I miss this time? You guys can do your own thing. I'm debugging my own program.
Have a good weekend. Happy Thanksgiving.
Same to you. Okay, it's still being recorded, so it's actually recording my own chuckle to my own bug. JCI to not know. Do you see any problem with this? Exactly. JCI is supposed to go to is null and not null because I have just found the null character. I have inverted the conditions. So that's why it said, I didn't find any characters in the string because it said, it just flipped it. Okay. So JCI should go to is null. Okay. Is null is here. And then JMPI to not null. There we go.
Your code was recorded, right?
Yep.
And we'll have time next week to work on it for the engineering lab, right?
Well, it's already done. So right now it's already done. I'm just waiting for the trace analyzer to finish, and then we can, if you can just stay for another 30 seconds, we can see
Is
that
this
it works.
recorded too?
Yeah, I'm still recording.
It's just I have to be at an appointment at 11. It's already 56.
Ah, okay.
Yeah, they called me. Yeah, like make sure you're on time. This is the first time I got a call.
I see.
Yeah, sorry.
Yeah, but it's already working. We can because I can see the return value is 3, and it returned all the way back to main. The stack is balanced, and they get to the halt instruction.
This is string length, right?
So right now it is being shared. So you want to get to it as soon as possible. Make a copy of that, and also the assembler.
Oh, okay.
So if you make a copy of those two right now, they will be reflecting the solution right now.
Okay, I'll do it on my
Yeah,
phone.
you can do it on your phone. Yeah. Yep.
Okay, cool.
Yep. Okay.
I'll see you next week.
Yep. See you next week.
Have a nice Thanksgiving.
Yep. You too. Okay. Just for the record, before I stop the recorder, just for the record, I fixed the program. So if you make a copy of the assembler and also the trace analyzer at this point, it is reflecting the correct implementation of the recursive version of string length. And I'm not going to mess around with this for a while, so you have some time to make a copy. So let me stop the recorder and then I'll answer individual questions.